What is the nomenclature used for odd days? So guys, in the later question, now we are going to see some more difficult questions, and this nomenclature will be used there, where we say that 0 odd days correspond to Sunday, 1 odd day corresponds to Monday, 2 odd days will correspond to Tuesday, and so on. 6 odd days will correspond to Saturday. Okay. If we have no reference day, if we have no reference day, so in that case, 1 will correspond to Monday, 0 will correspond to Sunday, and so on. 6 will correspond to Saturday. You can see on the left hand side of the PPT, one important information is written there. 1st January 0001 AD was a Monday. Okay. The 1st January, the very first date of our calendar. Okay. The very first date of our calendar was a Monday. Okay. So whatever concepts that we are going to discuss, or this nomenclature also, it has been made using this particular information. Okay. So odd days in different months. I believe you can very well calculate how many odd days are there in January. Now January is a month which consists of 31 days. 31 divided by 7 will give a remainder of 3, right? And that is why it is written that January will have 3 odd days. In case of February, you know that in ordinary year we have 28 odd days. 28 divided by 7 will give a remainder of 0. So that is why in an ordinary year, in the month of February, you'll have 0 odd days, while in a leap year, in the month of February, you'll get 1 odd day. Why we start our calendar with Sunday? Shivam is asking, sir, will it ask after 7 days or on the 7th day? Shivam, it will depend upon the question. Na? It depends, like if they are asking after 7 days, then you divide it by 7 and get the remainder. If they're asking on the 7th day, divide it by 7, get the remainder, and just go 1 day before. Okay. Mr. Chandan, I believe like there is no such thing as particular logic in this part. Okay. Monday was considered to be a working day, Sunday was not considered to be working day. That's all. I don't see a particular logic out here. Okay, now then comes the important part. Okay, especially if you are planning for some bank SSC exam, so this is the part where you need to pay more attention. Calendar problems can be classified into 2 broad categories. Questions that can ask you to find out the day of the week for the given date when some other date or date specified. Example, if 9th May 2020 is a Saturday, so 14th February 2050 will be what day? Okay. And the second type is questions that ask you to find the day of the week for the given date when no other date or day specified. Okay. So in the second category, you will not be given a reference date. You will be simply asked what is the day on, let's say 26th January 2050. Okay. So let's look into the first type of questions. Finding day with reference day. Okay. So let's look into this particular question first of all. Let's assume that today is 21st October and the day of the week is Sunday. And this is a leap year. Okay. So for any particular leap year, we have taken a Sunday and the date is 21st October. So the question is, what will be the day of the week on this day after 3 years? Okay. What will be the day of the week on this day after 3 years? So what should be your approach when you have a reference date and a day, and with help of that reference day and date, you are asked to find out the day on some other date. So your simple approach will be to find the net number of odd days for the period between the reference date and the given date. Find the net number of odd days for the period between reference date and the given date. The day of the week on the particular date is equal to the number of net odd days ahead of the given reference date. So in the first step, when you find the net number of odd days, let's say it comes out to be 4. So the answer will be 4 days after the given date. 4 days after the given day. Let's say if the given day was Saturday, So the answer will be 4 days after Saturday. Okay. So simple approach should be to find out the net number of odd days between the reference date and the given date. Clear? So for this particular example, 21st October, Sunday, leap year. What is the day after 3 years on the same day? So what is the solution? Since this is a leap year, so none of the 3 years will be a leap year, right? And if none of the next 3 years will be a leap year, so in the next 3 years, which will be a Wednesday. Okay. So I have already shown you the example so that we can. Is the voice gone, guys? Shivam, are you able to hear me? Okay. So very simple. Okay. You simply need to calculate the net number of odd days. Okay. I'll give you some questions to solve. Just try to understand this example so that you can solve the question which I'll be giving you. Okay. So you can just note this formula in your notebook as of now. The formula says that the remainder is date plus month code plus century code plus last 2 digit of year plus last 2 digit of year divided by 4 whole divided by 7. Okay. Now we'll come into the month code and the century code, but this is the formula. In the numerator there are 5 things. The date, okay, let's say the like if I give you 9th May 2020, so the date is 9. Month code for May, we will look into a table. Month code for 2020, again we will look into the table. Last 2 digit of the year. So in the year 2020, the last 2 digits will be 20, right? So we will write a 20 here. And then in the 5th term, we will divide this 20 by 4. Okay. Pranesh, the solution for X weeks and X days. Now, if I ask you how many days are there in 3 weeks, your answer will be 3 into 7, 21, right? So similarly, how many days are there in X weeks? So the answer will be 7 into X. Now, if I ask you how many days are there in 3 weeks and 2 days, so you will say now that 3 into 7 plus 2. So similarly, X weeks and X days will be 7 into X plus X. Shivam, thanks a lot. I appreciate it that you're liking the lessons. So guys, after you have noted down this formula, here is the month code. Okay. Now you will have to practice a little bit because you might get confused with the month code. It is 033614625 033614625 So remember it in this way, that the first 3 numbers and the last 3 numbers are almost similar. The first 3 numbers are 033, the last 3 numbers are 035. Okay. Now coming to the middle 6 numbers. So again divided into 3 parts. This is 614, this is 625. Okay. So I actually divided it in this way and I was able to remember it. You can frame a logic of your own, but you need to remember this. Okay. If you misplace any of the values, then the answer will come out to be wrong. Okay. Now this is the code for normal year. There is a slight change for the month code of a leap year. So the change is, guys, only in the first 2 months. Okay. The change is only in the first 2 months. Like in January, here it was 0. In January, here it is 6. In February, in normal year, you will go for 3. But in case of leap year, the month code for February will be 2. But from March onwards, it is exactly the same. So you need not worry. Okay. Yeah, guys, it is not that complex. You since you are reading it for the first time, so it might be difficult for you, but trust me, if you just spend 30 minutes on this part, you will not find it difficult. You need to remember this formula. You need to remember the month code and the year code. Remembering the year code is not a pain, guys. You can see the year code is simply any year from 1500 to 1599, the year code will be 0. From 1600 to 1699, the year code will be 6. From 1700 to 1799, the year code will be 4. From 1800 to 1899, the year code will be 2. So 0642, 0642. It is, you can see that it is like from 6 it is decreasing by 2, and this cycle repeats. So from 1800 to 1899 it is 2. Now from 1900 to 1999 it is again 0. From 2000 to 2099 it is again 6. So this cycle of 0642, 0642 keeps on repeating. Okay. Now for the month code, what you need to remember, that try to remember for the normal year. Okay. 033 for the first 3, and for the last 3 months it is 035. For the middle 6, 614, 625. And when it comes for a leap year, January and February changes. How does it changes? You can say that you just go 1 day back. Okay, so 0 odd days, go 1 day back, you get 6 odd days. 3 odd days, go 1 day back, you get 2 odd days. Okay, so once you are able to remember it, then let's look into how it helps. Okay, so the question is, what was the day? Yes, Tejan, from 2300 to 2399, it will be 0. Okay. So now let's look into this question. So guys, what was the day of the week on 17th June 1998? Okay. So let's quickly go to the formula. In the formula, the first thing is the date, right? So you can see that in the solution. Okay. The solution, you can see that in the 5 terms, the first one is 0. The date is 17. In the formula, the first thing comes is date, right? So that date will be 17. Now we need to go for month code and century code. The month is June, the year is 1998. So let's look into, now this 1998 is a normal year, right? So what is the month code for June? The month code for June is 4. So please remember, the first value was 17, month code is 4. Add 17 plus 4, that is 21. Then let's go for the year. The year is 1998. Check out in this box. Where does this 1998 comes? It comes under 1900 to 1999. So what is the year code? The year code is 0. So 17 plus 4 plus 0. So till now the sum is coming out to be 21. Let's look into the formula again. So 17 plus 4 plus 0. What are the last two terms? The last two terms are last two digit plus last two digit by 4. So here we have 1998. The last two digits are 98, right? So in this 21, I need to add a 98. That will give me 119. Okay. And then in this 98, I need to divide it by 4. So when I divide 98 by 4, I need to take the quotient. Okay. I need to take the quotient. So the quotient of 98 divided by 4, you can see it on your screen, it is 24. Okay. So guys, look into the first part of the solution. Year code is 0, month code is 4, date is 17, last two digit of the year is 98, and quotient of 98 divided by 4 is 24. So now what I need to do, I simply need to add all these 5 values. When you add all these 5 values, it comes out to be 143. When you divide this 143 by 7, you get a remainder of 3. And when you get this 3, then you need to look into this nomenclature used for odd days. In this nomenclature, you can see that 3 odd days corresponds to Wednesday. So accordingly, in this question, the answer will be option C, Wednesday. Clear? I will repeat once again, guys. You did not worry. The formula is date plus month code plus century code plus last two digits of the year plus last two digits of the year divided by 4. You need to add all these 5 values and divide it by 7. So in this given date, the date was 17, the month code, month is June, date year is 1998. So then you need to look into this table. In this table, the month code for June is 4, the year code will be 0. So year code is 0, month code is 4, last two digits of the given year is 98, and when you divide this 98 by 4, you get the quotient of 24. So then you just need to add all these values. After adding all these values, it is coming out to be 143. When you divide this 143 by 7, you get the remainder of 3, and 3 corresponds to Wednesday. Okay. Tejan is asking what will be the case if date is 17 June 1997. So simple, date is 17, month code for June. Let's look into the month code for June. It is 4. So 17 plus 4, 21. Then you get the year 97. Year code for 97 is 0. Last two digits of 97 will be 1997 will be 97. And then you divide 97 by 4, you get the quotient of 24. So when you add all these values, it comes out to be 142. And when 142 is divided by 7, you get a remainder of 2. So Tejan, the answer for your question will be Tuesday. Okay. So is this clear now, guys? See, I believe Tejan, you just saw how easy it becomes, right? If you note the concept, it will take hardly 30 seconds. Okay. So now here's a question for you. I want everyone in this group to answer what is the day on my birthday. Okay. My birthday is 30th May 1993. 30th May 1993. So tell me on which day I was born using this formula. What is the day on 30th May 1993? Okay. Everyone needs to answer on which day I was born. I will show you the month code and the year code. Okay. Here's the formula. Here's the month code and the year code. Take the help of this data and tell me. Okay. No one will take the help of your cell phone. Okay. Everyone needs to answer with the help of this data. I figured it out, Shivam. Yes, so the answer is Sunday. If all of you have used this data to get the answer, so now you can imagine, guys, that you might be doing it for the first time and it is taking you hardly 1 minute. With little bit of practice, the time will be less than 30 seconds. Okay, clear? Now, everyone, you have done 30 plus 1 plus 0 plus 93 plus 23. Let me discuss a simple mathematics trick which will further decrease your time. Okay. So what you can do is, everyone just look into your notebook. You have written 30 plus 1 plus 0 plus 93 plus 23, right? So let's say it is taking you more time in calculating the sum.
So what you can do is, for every 2-digit number, simply divide it by 7. Every 2-digit number divided by 7. 30 divided by 7 gives a remainder of 2. 93 divided by 7 gives a remainder of again 2. And 23 divided by 7 gives a remainder of 2. So now what you can do is, you can add all these remainders. 2 plus 2 plus 2 gives 6. Then you can see a 1 is also there now. 30 plus 1, so that 1 is also there. So 6 plus 1 becomes 7. And this 7 when divided by 7 gives a remainder of 0. So whenever you come across such cases where finding the sum is taking you more time, because when you use this formula, generally the sum will come out to be a 3-digit number. Okay, so what you can do is, you can simply like as soon as you get a 2-digit number, divide it by 7, take the remainder and use it in the formula. Okay, you can use it in the formula directly. Okay, so let's quickly look into this solution part once again. So in this solution where I got the sum as 143, let's say if I have done it in this way, 0 plus 4 plus 17. So 4 plus 17 becomes 21. 21 divided by 7 gives a remainder of how many? 0, right? So now I could have left the first 3 terms. So now let's simply go to 98. 98 divided by 7 gives a remainder of 0. So again, I could have left this 98 because the number of odd days still here is 0. And lastly, 24 divided by 7 gives a remainder of 3. So I could have simply said that in this sum, I don't know what the sum will come out, but the remainder will definitely come out to be 3. So that will be my final answer. Clear? So you could have followed this approach also. Now, let's look into the last part of this topic, repetition of calendars. So guys, I'll just show you what type of question comes. The question is, which upcoming year after 2007 will have the same calendar as of 2007? So there are 4 options. So you get these type of questions. So I'll simply discuss the solution. Okay, I'll simply discuss the solution. And what is the concept? So guys, here's a shortcut. The simple shortcut says that divide the given year by 4. Divide the given year by 4. If the remainder comes out to be 1, so the answer will be after 6 years. If the remainder comes out to be 2, the answer will be after 11 years. If the remainder comes out to be 3, the answer will be after 11 years. And if the remainder comes out to be 0, the answer will be after 28 years. Okay, so please just try to remember this shortcut. Hardly it will take you 10 seconds, hardly 10 seconds. Okay, the limitation of this formula is the given year and the upcoming year both should lie between 1901 and 2099, and I'm 100% sure that they will not ask you a question which is beyond this. Okay, what is the simple concept, guys? Whatever year is given to us, we will divide it by 4. Remainder comes out to be 1, answer will be after 6 years. Remainder comes out to be 2 or 3, answer will be after 11 years. And if the remainder comes out to be 0, answer will be after 28 years. Okay, logic, Shivam, it will take me at least 10 minutes to explain the logic. Okay, so that is the reason why I'm skipping that part for now. Let me try to answer it in 2 minutes. Okay, if I can. So repetition of calendar, you have seen the question, right? What type of question comes here? So what is the condition for 2 different years to have the same calendar? The condition, first condition is that both the years must be of the same type, right? So either both should be ordinary or both should be leap year. You agree to this fact, right? That the calendar of a leap year cannot be same as the calendar of an ordinary year. Both should be leap year or both should be ordinary years. And the second thing, 1st January of both the years must be the same day of the week. Okay, 1st January of both the years must be same day of the week. So this is the condition. Only then the repetition of calendars will be possible. Okay,
I'm getting some chats. Okay, so now let's see. I have also shown the normal solution here. The question was, which upcoming year after 2007 will have the same calendar as of 2007? So I will start from 2007. I'll start calculating the number of odd days. As soon as number of odd days comes out to be 7 or a multiple of 7, I will stop. Okay. So in the year 2007, you see 1 odd day, 2008 to 2 odd days, and this cycle keeps on going. And we see that when in the year 2017, after you get 1 odd day, the sum of these values is coming out to be 14. And when the sum comes out to be 14 odd days, when you divide this 14 by 7, you get 0 odd day. Okay, so therefore 2018 will have the same calendar as of 2007. For those people who want to know the logic for this solution, I would request you to simply drop me a message. I'll send you the link and watch the video. Okay, as of now, I am only concerned with teaching you how to solve the question in the best possible time. Okay, so